Hi everybody, welcome to the Unit 8A review, and this is adding, subtracting, and multiplying polynomials. So in number 1, we are asked to simplify, and I see that I have a plus sign. I'm going to be adding. So when I add my polynomials, I'm looking for like terms. So I'm going to highlight everything that has an x squared, and it looks like I only have one. So I'm just going to leave negative 2x squared all by itself. I can't combine it with anything because it's not like terms. So next I have positive 5x and positive 4x. So I know this one's positive, this 4, because there's no negative sign in front of it. So it's defaulted to positive. And I'm adding. So 5x plus 4x is going to give me 9x. And last, I'm going to highlight all of the terms that do not have a variable. These are called constants. So negative 10 plus negative 7 is negative 17. Notice my answer is in descending order of powers. Negative 2x to the second power plus 9x to the first power minus 17. No power on the negative 17. There's no variable. Okay, in the next one, I'm going to do the same thing. Again, I have addition. So I'm going to highlight all my w squareds. Now, when we don't have a coefficient in front of the w squared, we assume it's a 1. So I have 3w squared plus 1w squared. That's 4w squared. Those are called my quadratic terms. Next are going to be my linear terms. So I have 4w plus 6w, which is 10w. And last, I have my constants. So I have 12 plus 9, which gives me 21. Again, my answer's in descending order of powers. W squared plus 10w to the first plus my constant 21. Okay, in the next section, I'm going to subtract. I'm going to use the same exact process. So I'm going to highlight my t squareds. And again, I'm subtracting. So 4t squared minus t squared is 3t squared. Now my linear terms, 6t and negative 4t. Okay, now remember I'm subtracting. So I have 6t minus negative 4t. So that's 10t. And last, I have negative 8 minus 5. Negative 8 minus 5, which is negative 13. Again, descending order. Okay, again, I have subtraction. So I'm going to highlight all my m squareds. 4m squared minus 2m squared is 2m squared. Then I have negative 8m and negative 6m. So again, remember, I'm subtracting. Negative 8m minus negative 6m. Those two negatives become a positive. So that's negative 2m. And then I have 1 minus negative 3. 1 minus negative 3 is 4. Again, those two negatives become a positive. In the next section, I'm multiplying. So I'm going to set up my multiplication, my area method. Now I have a binomial times a trinomial. So my binomial and my trinomial. Sorry, it's like probably the ugliest box I've ever drawn. Okay. 2y times 3y squared is 6y to the third power. Because remember, this really has a 1 here. Same bases, I'm adding exponents. 2 and 3 are called coefficients. I multiply those. Then I have 2y times y, which is 2y squared, and 2y times negative 4 is negative 8y. Now I'm going to multiply through by my negative 5. So negative 5 times 3y squared is negative 15y squared. Negative 5 times y is negative 5y, and negative 5 times negative 4 is positive 20. Okay, looking for my like terms just like I was doing at the top. So these are like terms because they both have y squared. These are like terms because they both have a y. I don't have any like terms for my 6y to the third power or my positive 20. So those just need to go by themselves. I'm going in descending order again. So it'll go 3, 2, 1, none. So negative 15y squared plus 2y squared is negative 13y squared. And negative 5y minus 8y is negative 13y. And there's my final answer. In number 6, I only have a monomial times a binomial. So that's only going to look like this. And my monomial and my binomial. 3v squared times 4v is 12v to the third power. And 3v squared times negative 2 is negative 6v to the second power. Those are not like terms because I have v to the third power and v to the second power. So there's my final answer. These next two are one of our special patterns. So I see that I have the same and the same, but I have a positive and I have a negative. So I'm going to set up my box and I have 2p plus 6 and 2p minus 6. 2p times 2p is 4p squared. 2p times 6 is 12p. Negative 6 times 2p is negative 12p, and negative 6 times positive 6 is negative 36. When you look at your like terms, you should notice that one is positive and one is negative. So when I combine these, they cancel out. So I'm just left with 4p squared minus 36. In number 8, I actually have to expand this to x plus 3 times x plus 3. So when I set this up, it's actually a true square where both my length and my width are the same. X times x is x squared, of course. X times 3 is 3x, 3 times x is 3x, 3 times 3 is 9. These like terms do not cancel out this time because they are both positives. I'm just going to add them together for my final answer. This next one is just plain old distributive property here with my 6, and then I'll combine like terms. So 6 times r is 6r, 6 times 4 is 24, and then I'm subtracting 8r. My like terms are 6r and negative 8r, so that is negative 2r plus 24. And again, these are not like terms because the negative 2 is multiplied by r, but the 24 is not. Okay, just some quick exponent rules. So we have our coefficients that are going to multiply together. The same base, we're going to add exponents. Again, same base, add exponents. Perimeter means I'm going to add up all the sides. In this triangle, I'm told that it is equilateral, that they are all the same. That's what those tick marks mean. So add up all your quadratic terms. So I have 2x squared, 2x squared, 2x squared. That's 6x squared. Now I have 3x and 3x and 3x. That's 9x. And last, I've got 11 plus 11 plus 11. Since all three sides were the same, I actually could have done this and distributed. And I will get the exact same thing. 3 times 2x squared is, 6x squared. 3 times 3x is 9x. And 3 times 11 is 33. All right, there will be more in the next video.